Morning, everyone. So today we are going to present on the topic smart materials in civil construction, which includes self-sensing concrete, self-heating concrete, nanofillers, and sustainable materials. In this meeting, we will get to know about smart materials, self-sensing concrete, self-heating concrete, nanofillers, and sustainable materials. So coming on to the question, what is a smart civil structure? A smart civil structure integrates smart materials, sensors, actuators, signal processors, communication networks, power sources, diagnostic strategies, control strategies, repair strategies, and life cycle management strategies to perfectly perform any preset functions under normal environment and to confidently preserve the safety and integrity of the civil structure during the extreme event. These smart things include structural health monitoring, structural vibrational control, structural self repair, and structural energy harvesting. Structural health monitoring is the most important component of a smart engineering structure. It has the longest history of broad use across multiple domains such as civil engineering structures like tall buildings, bridges, and dams. Self-sensing concrete acts as a very good structural health monitor. It converts the external stimuli into stress strain sensing parameters. It also improves the serviceability of the structure as it reveals small cracks before they become significant. It also provides electrical resistivity to the structure. Self-sensing concrete is made by incorporating functional fillers such as carbon fiber, carbon nanotube, nickel powder. A combination of carbon fiber and carbon nanotube can create self-sensing concrete with superior mechanical, electrical, and sensing properties. Principle of self-sensing concrete. Self-sensing concrete employs a pyroresistive effect utilizing a conductive filler dispersed in a non-conductive matrix. The filler comprised of highly electrical sensitive particles forms a concentration dependent network within the concrete matrix. This network established around the percolation threshold is responsible to external loading. The concrete subjected to deformation or stress makes the conductive network disturbed. It changes the electrical parameters of the concrete matrix. The electrical parameters studied are capacitance, electrical resistance, and impedance of the material. The measurement of these electrical parameters determine the stress, strain, and damage caused to the concrete under static and dynamic conditions. The strain is measured by determining the electrical resistance. Now, coming on to the real life applications of the self sensing concrete, it has a very good use in traffic detection. Roads using self sensing concrete is one of the most successful application of self sensing concrete. This was demonstrated by a test section in Minnesota Road Research Facility near Albertville, Minnesota. The electrical resistance of the composite using carbon nanotube fibers would change proportionally to the level of compressive stress. Both precast and cast in self sensing concrete were used, and the system works very well and can be used for real time online detection of vehicles passing. It has the advantages of high precision, long service life, easy maintenance, and good structural property. The figure shows the test setup and also shows the advantages of self-sensing concrete over the conventional strain gauges. Now I would like to call Atul for the further presentation.
From here, I would like to proceed the presentations. Here, I am going to discuss about the self-heating concrete. Self-heating concrete is a clean technology that uses conductive material to heat concrete surfaces. It can be used for the variety of purposes, including de-icing. Self-heating concrete can be used to melt down the ice. One method is to embed carbon fiber heating wires inside the concrete slab. Another, we have indoor floor heating. It can also be used for indoor floor heating. Self-heating concrete can be used for electrically cure concrete. Hydration heat control. Self-heating concrete can be used to control hydration heat in a mass concrete. Next, we have purposes of usage is concrete casting. Self-heating concrete can be used for on-site concrete casting in a cold weather. From here, now I will like to talk about the type of self-heating concrete. Self-heating concrete is a type of concrete that consists of phase change material, uses a liquid paraffin that releases heat when it changes from liquid to a solid. The material allows the concrete to warm up slowly, especially in sub-zero temperature. Self-heating concrete can keep snow and ice off-road, and it is a greater alternative of road salting. For example, slab of concrete containing PCM can maintain surface temperature of 40 to 55 degree Fahrenheit for up to 10 hours, which is enough to melt down the rate of ice about the 1/4 inch per hour. Another type of self-heating concrete is electrically conductive concrete, which is shortly called as ECON, is a type of concrete that can be heated usually electric conductive fibers, such a carbon fiber or steel fiber. When electric voltage is applied, the heat produces from the econ can melt ice and snow on the pavement. Econ can be used in the heat pavement system, but the field scale implementation is not yet common. Moving to the multifunctionalities and applications of self-heating concrete. Multifunctionality consists of taking advantage of structural material itself is a developed non-structural function without the need of any type of external devices. Multifunctionality achieved by combining a cementitious material with a different addition that provide a resulting material a new range of applications. This study may serve the base for the many applications that a cementitious material capable of increasing its temperature in a controlled manner would have, such as evaporating the rainwater of sport court, heating the room through the walls, floors, or melting the ice off road on a runway of an airport without use of salt. Thus, the application and ice control or on a different transportation infrastructures, the safety of driver could be increased while compromising the durability of structure with the use of substance that can damage it. Now, talking broad about the electrically conductive concrete, heated up pavement system in a newly developed clean technology to reduce the use of polluting chemical for the removal of snow and ice. This technology requires further comprehensive study for achieving the energy efficient designs. Now we have some statistics about heat electrically current applications. Here we have the graph of temperature versus time. Here we can see that electric current and the temperature variation in different layer of the pavement and the ambient temperature. Thank you. Here I will like to call Pavanjan for the next presentation about the sustainable material.
Thank you, Atul. Now we are going to talk about sustainable material. Sustainable material have the following characteristic like eco-friendly, minimal resources, waste-free, non-polluting, energy efficient, cost-effective. When we talk about sustainable material, these materials are materials that create a stable system without exhausting non-renewable resources. Why there is a need for sustainable material? Cement industry carbon footprint is a significant environmental concern. Cement production ranks among the top contributor to greenhouse gas emissions following power plants. Globally, about 4.1 billion metric tons of cement are produced annually, contributing 8 to 10% of anthropogenic, that is human-made CO2 emission. Concrete production at this scale significantly affects energy, resources, and the environment. And we are going to talk about sustainable material in concrete construction. What types of material are optimal? Materials like AAC, green concrete, red brick, monolithic concrete, that is called Divine. When we talk about the properties of the AAC, that is autoclaved aerated concrete, that it has the lowest RETV value, that is residential envelope transmittance value. It given by the ENS, that is Econivas Sahinta, a metric measuring heat transfer through a building envelope. These are the better balance between embodied energy and construction time. When we talk about green concrete, it has the following advantage: reduction in shrinkage and creep, use local and recycled material. And green concrete is also eco-friendly concrete. Here we have the following, that a company measuring materials, that the RETV value. Based upon the RETV value, we can see that the AAC concrete have the lowest RETV value. That is eco-friendly. Sustainability of material helps to achieve what we achieve through the sustainability of material, that we achieve SDG goals, Sustainable Development Goals sustainable development goals in the field of the people, environment, society, and means. When we achieve Kyoto Protocol under UNFCCC in Conference of Party 3. We achieved Paris Agreement 2015, under which India targeted to cut 33 to 35% of the carbon emission, that is greenhouse gas emission. And we also achieved COP Conference of Party 26 Agreement. Initiative towards sustainability. We taken major steps like Econima Samhita 2018, India Cooling Action Plan. India Cooling Action Plan forecasted that there is a demand for cooling, eightfold increase in the cooling plan from 2017 to 2037. Energy Conservation Building Code 2017, and we have Green Building Rating System, Zero Carbon Building Action Plan, that is ZCBAP, that is followed by the Nagpur action. And I'd like to end up this meeting. This is presented by Karthik Mittal, Atul Kumar, and Pramanjan Kumar.